Good afternoon, everyone, and welcome to this edition of the NITheCS Micro-school. My name is Dean Brand. I'm a second-year PhD student in quantum computing at Stellenbosch University, working with Professor Francesco Petruccioni, who is the director of NITheCS. And today's topic will be getting started with cProfile, which is a performance-focused package in Python, with a lot of tools for performance analysis for programs written in Python. The speaker today is Eleanor Kedem, who is a third-year master's student at UCT, working in the AI program, also with Professor Francesco Petruccioni, among other supervisors, on quantum-inspired algorithms. She earned her bachelor's in computer science as well as an LLB, all in Tel Aviv, with a heavy focus on algorithms and AI. So she's the perfect person to be telling us about performant code in Python. With that, I would like to hand over to you, Eleanor, and to our participants. If you have any questions or suggestions for more micro schools, please feel free to put them in the chat. Take it away, Eleanor.
Thank you, Dean. Thank you so much for the introduction. And yeah, I was the reason that I got into cProfile and also was very excited about it is because I was trying to do benchmarking, and I found this tool to be immensely useful. Simply because it gives you really good statistics, really good information about your code. It could easily find all the bottlenecks and all the problems in your code to improve your performance. And just before I start, why do we need good performance? Obviously, this is a bit of a stupid question if you're a computer scientist, because, you know, of course we want a good performance. But the other reason is that, well, other than our resources, what we can do with all our resources, the other reason is obviously that without a good performance, some of the problems that we have are not solvable with a computer. So we obviously want a good code, and this allows us this tool allows us to solve that problem. So initially, Python has the time library. The time library allows us to literally time, you turn on the time and then you measure the time at the end of your code, and you are able to see how long your code has been running for. And this was a nice tool. The problem is that if you've got lots of nested functions and you have a few things that, your code is long, let's put it that way. Your code is long, is complicated. To be able, with the time library, with the Python time library, to actually tell where is your bottleneck, how to optimize your code is very difficult. Sorry, it's very difficult, because you would have to literally take every snippet of your code that potentially creates a bottleneck and time this particular code. And yeah, it's a long process. Then Profile came along. Profile is a library that is written in Python. And the problem with this library is that because the profile is a heavy load on the code, actually, when you profile your code, it creates an additional burden of your code, which is why the cProfile was initiated. The cProfile is written in C. C is a tremendously faster language than Python, and hence it doesn't burden as much to your code. It does a little bit. I mean, if you are in production phase, etc., you don't want to run a profiler. But the cProfile is smoother, quicker, and yeah. And this is what I am going to present today. Let me share my screen. And let me take you to the code. So I've initiated a short code that just a showcase of what the cProfile can do. As you can see, it's three very stupid functions. One is simply sleeping for a second. That's the slow function. The medium function is a function that runs the slow function for 5 counts. And the fast count function just calls the medium function and gives a printout. In order for us to, well, time is for to give us the sleep, but in order for us to be able to use the cProfile, we have to import it, and it's built in, so you don't have to do anything other than that to install. So let's run the code and see what it does. So I'll put on my sophisticated glasses. As you can see, there was not many printouts during the code. It's just the printout of the fast function. And we can see from here the statistics that are being given by the cProfile. The first column is the number of calls. So the profiler called the fast function called the medium function, and the medium function called the slow function. So when we enabled the profiler, it was before we called the fast function, and that was called once. So we can see that the number of calls for the fast function is 1, and the medium function within the fast function is 1, and then the slow function is called 5 times, because the medium function calls the fast function, the slow function 5 times, sorry. And also the time sleep is called 5 times. Notice that the order is by the standard name. This is the go-to or the default ordering of the statistics. I'll show later on different ordering. Sorry. The total time is the time that is spent in each function, exclusive of other functions. So we can see that the sleep, within the sleep, exclusive of other functions, you spend 5 seconds. But all the other functions, they don't really do anything, right? So despite the fact that they are called, all of them are called, and you would see that the cumulative time is much larger, the total time, how much time you spend in each function, is 0. Per call obviously was also per 0, and other than the time, which is, as we know, a second per call. And then the cumulative time is inclusive of other functions, how long it took you to be in that function and then to exit that function. So this is in general what the cProfile does. It gives you a very profound diagnosis or statistics of all the functions that there are in a particular code that you choose to ask for the diagnosis of. We could also run that profiling. We could also run from the terminal. I'll just sorry, I've got this already written, so it's going to be a lot easier. Sorry. And then we can see that it's going to run the code. It's going to be a little bit longer because it's running the terminal as well. It's running the code. The statistics are pretty much the same. It gives all the other functions. If you're running from terminal, it gives all the other functions that are actually running in the background of that run. which are, irrelevant for your statistics of your particular code, obviously. So it's easier to run from the code. But if you don't have, or you don't want to have a direct access to your code, or you don't want to change your code, this is an easy way to bypass it, to run through the terminal. I was talking about the statistics and how to sort them. So let me unmark this. We can change the ordering, and we can collect the statistics. I'll show later how we can also collect it into a file. We can collect the statistics and we can sort them. We can also decide how many of them we would like to have printed. Assume that you've got, I don't know, 1,000 functions, or, well, maybe that's a bit of a big code, but, you've got 100 functions that you want to run, and you don't want to see all of them. You don't want to see the statistics of all those functions. So you can decide that you want to see only the first 10 of them. And then you can decide if you want to run it by the cumulative time of how long it takes you to spend in each function, or maybe you want to just do the total time because you want to see which function is actually taking the longest to run. So let's run the code now and see that the ordering has changed. As we can see, the first function is now the first one, with the medium function that was first. Now it's second, because it was, before that, it was ordered by name. And the cumulative time, obviously, for the fast function, because it's the first function that's being called, it's the longest. And yeah, we can order by any of the other columns, as by name. There are other options to order, which are less interesting, I would say. The last option that we have is to dump the stats into a file. That file is not readable. It's a binary file. So the way to actually use it afterwards is we can copy this. And then we can run it. And what it's going to do, oh, no. That was wrong, sorry. We don't want it from the profiler, we want it from the file. And actually what it's going to do is it's going to do exactly the same, because, we're writing to a file and we're reading from a file. It doesn't going to give us any different statistics. The added value of this is that cProfile also comes with a few applications that allows you to visualize your statistics. And this, if you've got long statistics and it's not just a simple 10, or in this particular case, it's 6 rows of statistics, and you've got a lot of them, and you want to visualize your results in order to see where is your bottleneck, what you need to improve, what you need to optimize. This could be very handy. And just to show how this actually works and how I actually worked with it, I'm going to show you a part of my research. This card has 3 different algorithms that are going to run the same Cubo problem. Cubo is a quadratic unconstrained binary optimization problem. The long and the short of it is, I mean, it's not that interesting, but well, it is, but not for that discussion. There is a matrix, and that matrix sets a relations between parameters of the problem. The problems that I'll be looking at has got 50 parameters. And the three algorithms are trying to solve that problem. We want to check which one of these algorithms is works better for that particular problem. Sorry. This is how this one, obviously, you know, it's easy to see, or it was easy to understand why this this code, the cProfile is good for optimizing. But this particular case also shows why it's great for benchmarking, because we could take any particular run of our main function and run the cProfile on that main function. And well, obviously for me, it was good to see where my bottlenecks are, but I was clearly able to benchmark between the three algorithms and see which one of them is more efficient, what part of the algorithm is taking me more time, so I could actually benchmark and identify where the algorithms make it difficult to run efficiently. I ran it, but let me run it again. So you could see that one of the algorithms is significantly slower. This is the third one, as I don't know if you managed to see. The first two ones were pretty quick. And the third one was significantly slow. We could see that the results, that the cumulative time of that, it's all of them are running the same method, the minimize method of the three algorithms. You could see that this is minimized and this is minimized and this is minimized. So this is the main method of minimizing that Cubo problem. We could see that the cumulative time for the first algorithm is, well, less than 1/10 of a second, and also the other algorithm ran pretty quickly, while the third algorithm ran, well, over 2 seconds. We could also, like I said, we could also analyze within which are the parts that took us longer. So we could see which are, some of the functions are functions that obviously that Python is using it. It doesn't need to be necessarily your functions. If you do print, then it will also say print. If you do a dictionary, if you do listing, it would also give you the list of, analyzing the list or reading from a list. But at the end of the day, it's probably what your code has in it that gives the actual overhead, and you can solve it. So that's basically it. That's cProfile. If there are any questions, I hope I'd be able to answer them.
Yeah, thank you. Well, that was great and very interesting to see how easy it is to work into your already present workflow to see very useful stats about your code. So yeah, if there are any questions, please feel free to put them in the chat or raise your hand, or we can interact and unmute your mic and talk and ask all you like. But I think it was a pretty thorough talk. So if there are no questions, it would also make sense. Yeah, seems a pretty satisfied audience.
Well, thank you for everybody for listening, and I hope I made somebody's life easier. I mean, I know that for me it made a huge difference. I was struggling with time to to measure where my issues are. And like I said, this cProfile made things so easy that at the beginning I felt very guilty that I'm not analyzing the code, and timing each particular function or method that I was using. But yeah.
Yeah, I know even in my experience, this is going to really be very beneficial because I do it in a very clunky way of just having a start timer and then an end timer afterwards, or just watching my code as it runs and then measuring with
Yeah,
a
yeah,
stopwatch how long it takes. But this is much better.
yeah.
I see
I
there's a
love that.
question in the chat asking, is the library available online? Is it a pip install or is it a built-in? Or
No, so it's a built-in. That's what I said at the beginning. You don't have to do pip
yeah,
install. It's a built-in library. And yeah, what I didn't show quickly. So let me just share that screen. Again. So sorry, I can't move it. Yes. All right. So in order to use the cProfile, you have to do, like I showed at the beginning, you have to import the cProfile in order to do the stats and to actually be able to sort the stats and to save them in a file, you have to import bstats. But both of them are built in and no pip install is required.
great, even easier.
Yeah.
Yeah, I think everyone seems to be happy, and I know I definitely learned a lot, and I imagine everyone else did as well. I see in the audience, everyone is also pretty happy with this new, very useful tool. So thank you, Eleanor, again for a very great talk and a very useful tool that you've shared with us. Really
Thanks,
appreciate it.
Alar.
Yeah,
Thanks,
so
and see you next time.
yes, see you soon. Yeah. Goodbye, everyone. Great. Perfect. Thanks, Eleanor. That went very
Thanks,
well.
Dean.